lab was to explore electrophoresis and DNA manipulation. In the early days of science, DNA was separated by gravity, but in the 1950s, DNA gel electrophoresis was discovered by Oliver Smithies. In gel electrophoresis, proteins and nucleic acids are electrophoresed inside a matrix or gel. This gel is cast in the shape of a thin slab with wells for loading the sample. The gel is immersed within an electrophoresis buffer that provides ions to carry a current and the running buffer to maintain the pH at a relative constant value. The gels that can be used are agarose and polyacrylamide depending on the specification of the sample as well as procedure. Once the DNA is cut, normally by restriction enzymes, it's charged into the wells. When the electricity flows, the DNA is pulled from the negative side to the positive side because DNA has a negative charge. Agarose is a polysaccharide that is extracted from seaweed. It can be used in varying concentration of 0.5 to 3%. The higher the agarose concentration, the denser matrix and vice versa.
First, set the mold on a horizontal section of the bench and make sure that the area is completely flat and even. After preparing TAE buffer, put 0.5 grams of agarose in an Erlenmeyer flask with 50 milliliters of TAE buffer. Heat the mixture in a microwave oven until the agarose dissolves. Do not allow the agarose to spill out. Check the mixture, and if it's not clear enough, put it again on the microwave. Make sure to use insulated gloves to remove the flask from the oven, because if not, you can burn yourself just like I did. If you don't have gloves, you can use a piece of paper. Mix properly using your wrist and not your arm. To dye the agarose gel, you will add the ethylene bromide to the gel solution before it solidifies. When the agarose solution is cooling, choose an appropriate comb for forming the sample slots in the gel. Position the comb from 0.5 to 1 millimeter above the plate so that a complete well is formed when the agarose is added to the mold. Pour the warm agarose solution into the mold. Allow the gel to set completely for about 30 minutes at room temperature. Carefully remove the comb, trying not to break the gel. Cover the gel with buffer and mix 4 microliters of your DNA sample with 1 microliter of loading buffer. Slowly load the sample mixture into the wells of the submerged gel using a micropipette, glass capillary tube, or a Pasteur pipette per sample. Load size standards into slot on both sides of the gel. Close the lid of the gel tank and attach the electrical leads. Apply a voltage of 100 volts for 30 to 45 minutes. Keep an eye on the loading dye migration, as 2 color bands should appear on the gel. Run the gel until the propofenol blue have migrated an appropriate distance through the gel. To stop electrophoresis, turn off the electric current and remove the lids and lid from the gel tank. Visualize the gel using UV light in a transilluminator and capture the gel image on the digital camera equipped with an UV emission filter. Send the gel photograph to your email account.
In this practice, we had to apply different lab abilities in order to complete successfully the electrophoresis technique, such as pipetting, measuring, and preparing gel. Despite we have already done some electrophoresis gel preparations, we had some difficulties at the time of pipetting the DNA samples and the loading dye into the wells. Anyway, the electrophoresis went right, and we obtained a gel image of our samples through UV light in a transilluminator, which results were a bit confusing, since only the plant's DNA samples can be observed and the blood ones don't. We have reached the conclusion that this is because the blood DNA didn't have good quality or it was contaminated with nucleases. Also, there are better techniques to visualize blood DNA, such as pulse field electrophoresis or PCR. Meanwhile, the plant DNA samples look smeared, and there are some possible causes, such as it was not fragmented at all with endonucleases, it was degraded or deneutralized. Electrophoresis is a very important technique in genetic engineering, and it is important for us to understand and master this technique. It is a simple technique, but it needs practice, which will improve our abilities.